Hello, this is a video for the Random Variables and Stochastic Processes course. In this short video, I'll be introducing the concept of random variables and the type of random variables. We have looked at the evolution of the theory of probability. The first breakthrough was when probability was formalized using set theory. The classical or naive definition using outcomes or events and sample space was very useful in many cases. However, this cannot be used in many real-life scenarios. For example, the probability of life on a newly discovered planet. Development of the axiomatic definition of probability was another breakthrough. However, there is still the issue when events are complex and we cannot calculate or count the number of outcomes in a sample space. Now we'll introduce random variables. In any experiment, the randomness comes from the uncertainty in the outcome. What that means is, even though we know the possible outcomes, we are not sure what exactly the outcome is going to be when we do the experiment. Where outcome is an element of the sample space and event is a subset of the sample space. Contrary to the name, random variable is not a variable, but it is a function. The input to the function is the sample space, which is also the domain, and output of the function is a number on the real line, which is also called the range of the function. So the random variable maps the outcome of an experiment to a number. Consider an experiment with sample space denoted as S. A random variable is a function that assigns a real number to each outcomes omega I to the real line. Mathematically, it's denoted as this, where R represents the set of real numbers. The random variable is usually denoted by a capital letter such as X. Let's look at an example where we toss two coins. In this experiment, the sample space consists of four outcomes: head head, head tail, tail head, and tail tail. Let's define a random variable for this experiment as the total number of heads. So if you look at this table, the first row lists all the possible outcomes, and the second row has the random variable where we count the number of heads in this experiment. So X can take values between 0 to 2. We can define many random variables on this same sample space. For example, instead of counting the total number of heads, we can say the random variable is the square of the number of heads in this experiment. In general, a random variable can be considered as a summary of the experiment. Once the experiment is performed, the outcome is mapped to a number. Let's look at another example of throwing a die. Define a random variable for the number that shows up in the die experiment. So the sample space consists of numbers 1 through 6. We can define a random variable x of omega is equal to omega, which means x of 1 is equal to 1. We can also define another random variable y, which is 10 times of omega. So for this experiment, we have the outcomes 1 through 6. X takes on values between 1 to 6 and y takes on values 10, 20, 30 and so on up to 60. We generally don't mention omega when you're writing a random variable. Instead, we just write the capital letter X or Y to denote a random variable. Now let's look at different types of random variables. First, we look at discrete random variable. A random variable is discrete if the set S consists of outcomes that are countable. These types of random variables are usually associated with experiments that consist of counting something. For example, the counting of number of heads. A discrete random variable has a finite number of possible values or an infinite sequence of countable real numbers. Examples: number of customers who arrive at a bank in a given time window, number of runs or goals scored in a match. Contrarily, continuous random variable can take values on a continuous scale, usually associated with experiments that measure something. A continuous random variable can take on infinitely many possible outcomes or values. Example: waiting time between successive cars passing a given point, the height or weight of people in a group, batting average of a player in cricket. A mixed random variable has both discrete and continuous components. For example, continuous for one subset of the sample space and discrete for another subset. Let's look at a concrete example. Modeling the amount of time taken for a bank to complete customer tasks. So for some transactions such as cash withdrawal, the unit of time can be number of minutes and it can be discrete. So it can take on values like 1, 2, 3 and so on, measured in minutes. For some other type of transactions in the bank, such as a loan application, time can be more accurately represented as a continuous time. So the random variable in this case can be discrete or continuous based on the transaction time and thus a mixed random variable. Another random variable type that's used frequently is called an indicator random variable. Let's look at an example to understand. A battery's operating life before wearing down. In this example, the life of the battery can be a continuous random variable. But if you consider the event E, that the battery lasts for more than 2 years or not, in this case the random variable on E can be defined as x is equal to 1 if the battery life is greater than or equal to 2 years and 0 otherwise. So it takes on values of 0 and 1. Such type of random variables are known as indicator random variable. X can either be 1 or 0 depending on whether or not E occurs. That brings us to the end of this video. In this video we learned what a random variable is and the type of random variables using some examples. Thank you.